Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening, ma'am.
Good evening. My presentation is visible, right?
Yes, ma'am.
Okay. So on your screen, you can see all the cards in one pack of playing cards. A pack of playing cards has 52 cards in it, not including the jokers, not including the extra cards, the jokers. So a pack of playing cards has 52 cards in it. They are divided into 4 suits. 52 cards are divided into 4 suits. So what you see here, the first row, you can see all the cards of clubs. You can see all the cards of clubs. The first row, you can see all the 13 cards of clubs. The second row, you can see all the 13 cards of spades. The third row, you can see all the 13 cards of hearts. And the last, fourth row, you can see all the 13 cards of diamonds. So individually, when I have to refer to this card, so there are, okay, let me tell you about the cards first. So each suit, so these are the 4 suits: clubs, spades, hearts, and diamonds. These are the 4 suits. Each suit has 13 cards in it. Each suit has 13 cards. You can count. Every row has 13 cards in it. Every row has 13 cards in it. You can count. So instead of 1, we have A. Instead of 1, we have A. Then 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, and King. A is the ace card. This is the ace card. ACE, ace card. So there is 1 ace card. Every suit has 1 ace card. Every suit has 1 ace card. 9 number cards. And 3 picture or face cards. Because you can see the picture. You can see the face of the Jack. You can see the face of the Queen. You can see the face of the King. So you can see it here also, of course. You can see it below here also. So since you can see the face of the Jack, King, and Queen, these 3 are called in every suit, these 3 cards are called the face card or the picture card. Face cards or picture cards. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Every suit, every suit. Now when you take up all the 13 cards in clubs, when you take up all the 13 cards in clubs, you will see that there is 1 ace card. So 13 minus 1, 12. 3 face cards. So 12 minus 3, 9. The remaining 9 are number cards. 1 ace card, 3 ace. I said ace. 1 ace card, ACE. 1 ace card, 3 picture or face cards, and 9 number cards. So every suit has 1 ace card, 9 number cards, and 3 face cards. So in all, how many face cards do we have? All the 4 in a pack of playing cards. In a pack of playing cards, how many face cards we have?
12, ma'am.
12. Every suit we have 3 face cards. How many face cards do we have in the black suit? How many black suits are there?
Ma'am, two, ma'am. Two, ma'am.
Two black suits
Two
and
black suits and
yeah.
two black suits and 6 face cards, ma'am.
Correct. How many red suits do we have?
Two
Two.
red suits, ma'am,
Two
and
red
6
suits.
face cards.
Name the red suits. Name the red suits.
Hearts and diamonds, ma'am.
Hearts and diamonds. And the black suits.
Spades and clubs, ma'am.
Clubs and spades.
Yes, ma'am.
How many ace of black we have?
Two, ma'am. Two,
Two,
ma'am.
ma'am.
Yeah, we have two ace of black. How many ace of spade we have?
One, ma'am.
Only one. There's only one ace of spade, but we have two ace of black.
Yes,
How
ma'am.
many ace cards we have in all?
Four, ma'am. Four, ma'am.
Four. We have four ace cards in all. We have four ace cards in all. How many picture cards in all?
12, ma'am.
How many red picture cards?
12, ma'am. 6, ma'am. 6, ma'am.
Yeah, red picture cards 6. How many red number cards?
20, ma'am.
18. Red the number cards. Red number cards. 9 plus 9, 18. There are only 9 number cards. You can count. I'll wait. You count. From 2 to 10 you count.
I took A's also by mistake, ma'am.
Yeah.
Yes, ma'am, me too.
So we have nine number cards. Yeah, we have 9 number cards in each suit. In each suit, we have 9 number cards. So 9 into 2. 9 of hearts, 9 number cards of hearts, and 9 number cards of diamonds.
Diamonds.
So 9 plus 9, 18. 18 number cards we have of red.
Yes, ma'am.
We have 18 number cards of red. We have 18 number cards of black also.
Yes, ma'am.
How many cards are multiples of 5? How many cards do we have which have the number which is a multiple of 5?
2, ma'am.
8. All the 5s and all the 10s. How many cards we have which bear the number which is a multiple of 5?
Yes, ma'am, I have mentioned only for 1 second.
Okay. So all the 5s and all the 10s.
Yes, ma'am.
In a pack of playing cards. So when we say a pack of playing cards, we are talking about all the 52 cards. In all the 52 cards, we have 4 plus 4, 8. We have 8 cards which bear the number which is a multiple of 5. Okay. How many cards have a prime number on it? How many cards have a prime number on it? You first find for one suit and then multiply by 4. That's all. Find in one suit. In one suit, how many prime numbers we have?
3, ma'am. 2, 3, and
7. In one suit, how many prime numbers?
2, 3, 5, and 7, ma'am.
5, 7, ma'am. 4, ma'am.
2, 3, 5, and 7. The number 2, all the cards. Okay, the card which has 2 on it, 3, 5, and 7. 2 cards bearing the numbers 2, 3, 5, and 7 are cards which have prime numbers on them. So in one suit, we have 4 cards, 2 card bearing 2 on it, 3 on it, 5 on it, 7 on it. So 4 cards, 4 into 4, 16. 16. All right, now answer these questions based on probability. So now you pick a card, okay? You are asked to pick one card out of these 52 cards. So when it's probability, the denominator will always be the total number of cards, which is 52. The denominator will always be 52 because we have 52 cards in all. Only the numerator will change based on the favorable number of cards. So you have to pick a card at random. Randomly, you'll have to take one card from these 52 cards. What is the probability that it will be a king card? What is the probability that it will be a king card?
4 by 52, ma'am.
4 by 52, ma'am.
4 by 52. Because how many cards are favorable for you? Because you want to pick a card and you want that card to be a king card. So how many cards are favorable for you? 1, 2, 3, 4 kings are there. So 4 kings, 4 out of 52. 4 by 52. And that simplifies to
1 by 13, ma'am.
1 by 13. That simplifies to 1 by 13. So your probability, the probability that the card you pick will be a king card is 1. You have one chance out of 1. The probability is 1 out of 13. What is the now again a different situation. Again you have to pick a card from a pack of playing cards. You'll have to pick one card. What is the probability that it will be a face card of black? Face card of black.
6, ma'am.
6 by 50, ma'am.
6 by 52. 6 by 52. It'll be a face card of black. Face card, and it should be of black. So 3 plus 3, 6. Should be a face card of black. So 3 plus 3, 6 face cards of black by 52. And that simplifies to? That simplifies to? What happened? Are we there? Am I audible?
Yes, ma'am. 3 by 26, ma'am.
3 by 26. 3 by 26. What is the probability that it will be an ace of hearts?
1 by 52, ma'am.
Again, same thing. You have to pick a card. What is the probability that it will be an ace of hearts?
1 by 52. 1 by 52, ma'am.
Only one card we have. Ace of hearts, we have only one. So
Yes.
1 by 52 is the probability.
Yes, ma'am.
What is the probability that it will be a number card of a red suit? Number card of a red suit.
18 by 52, ma'am.
18 by 52, because we have 9 plus 9, 18 number cards of red. We have 9 plus, because we have understood the distribution of cards. No, in every suit we have 3 face cards, 1 ace card, and 9 number cards. We have understood the distribution of the cards in each suit. There's only 1 ace card, 3 face face cards, and 9 number cards. So 9 plus 3, 12, 12 plus 1, 13 cards we have in each suit. Into 4, 52 cards. So if you're asked if you have to pick a card, and the probability that the card will be a number card of red suit, the probability is 18 out of 52. 18 out of 52.
Yes, ma'am. Yes, ma'am.
Okay. Now you have a pack of 18 by 52. You should simplify. Never leave the answer like that. It should be simplified. So 9 by
26.
9 by 26. 9 by 26. Always simplify. Okay. So now supposing all the jack cards are removed. All the jack cards are now, that is, you have a pack of playing cards, and from that you remove all the jack cards. All right. You remove all the jack cards. Now, what is the probability? So you have to pick a card at random. I'll come from the beginning. You have a pack of playing cards, and from this you remove all the jack cards. from the remaining cards, you have to pick one card. What is the probability that the card you pick will be a face card?
Ma'am,
The probability
8 by 52, ma'am.
8
What is the probability that the card you pick will be a face card?
8 by
8, ma'am.
1 by 1, 1 by 1. Yes. Tell your name and give the answer.
Ma'am, I'm Sindhu, ma'am.
Yeah, what's on?
Ma'am, 8 by 48, ma'am.
Okay. Others?
Ma'am, 8 by 48, ma'am. This is Devadashi, ma'am.
Okay.
Ma'am, Madhumita, 8 by 48, ma'am.
Okay.
Ma'am, 8 by 40.
Okay. Is anyone else there?
Ma'am, 8 by 48, ma'am. I'm Danya.
Okay, 8 by 48. So I'm sure all of you, no, I'm now assured that all of you understood. Yes, it is 8 by 48. So first, when you remove all the jack cards, the number of cards reduces. So 52 minus 4, 48 cards. So the denominator will be 48, not 52, because you've removed 4 cards.
Yes.
So 52 minus 4, 48 will be the denominator. Now when you have to pick a face card, actually there are 12 face cards, but you've removed all the jacks. So now on 12 minus 4, there are 12 face cards. But 4 jacks have been removed. So 12 minus 4, 8. There are only 8 remaining face cards. So 8 by 48 is the probability. There'll be 8 in the remaining set of cards. There are only 8 face cards out of 48. 8 by 48, which is 2 by, no, 48, 8 by 48, no, 6 8s are 48. So 1 by 6. 8 by 48 is 1 by 6. So that's all. The questions will be something like this. So you just have to be sure about how the cards are distributed. All that we discussed, if you understood whatever we discussed now, you're good to go. Is this fine, children?
Yes, ma'am.
Okay.
Yes.
Okay. So this was a little portion from probability. Now let's get back to algebraic identities. Did we have time to complete this assignment?
Ma'am, we completed the 6th question, ma'am.
No, 7, 8, 9, 10 was it meant to be completed as homework? No, right? No?
Ma'am, you gave it as homework, ma'am.
All of you completed, is it?
Yes, ma'am.
Okay. Then I should unshare my screen. Is there anyone who has not completed?
Ma'am,
Yes, Raja.
I did not attend last class.
But the meeting recording was shared, no? Did you go through that?
Excuse me, ma'am.
Out of
No, one by one. Raja, yes.
Today only I came home.
Oh, okay. Please go through. It's an important one.
Yes, ma'am. Sure.
It's a revision based on this chapter, algebraic expressions and identities. Please go through the video. Yes,
Yes.
Madhumita?
Ma'am, I finished watching the meeting recording and finished my test today morning, ma'am, but I couldn't do the homework as I had school.
Okay.
Ma'am, and I'll complete the test within tonight, ma'am.
Who's this, Madhumita?
Yes, ma'am.
Okay. Okay, those who have completed the homework can share your answers. Others, once I show the answers, you can take a screenshot and complete it later. Let me unshare my screen now. Yes, we discussed the sixth one, or we should start from there.
Ma'am, we should start from seventh one, ma'am.
Seventh one. Oh, seven. Yes, one of you read out the answer from your book.
Ma'am, the answer for first.
No, answer. No, not answer. The step. How have you worked this?
Yes, ma'am. Ma'am, for this question we must find out the LHS, and the first step is 3x plus 5y into 3x plus 5y minus 30xy, ma'am.
Okay.
The second step is 3x square plus 2 into 3x into 5y plus 5y square minus 30xy, ma'am.
Okay.
The third step
But
is.
why did you write 3x plus 5y as? Why did you write 3x plus 5y the whole square as 3x plus 5y into 3x plus 5y? That was not needed. Directly you can do no a plus b the whole square is a square 2ab b square.
Yes,
You
ma'am.
don't have to write it as 3x plus 5y into 3x plus 5y.
Yes, ma'am.
Okay.
Ma'am, then
Okay.
then the next step is 9x square plus 30x plus, ma'am, 9x square plus 25y, ma'am. The answer I got, ma'am.
Okay. Very good. Very good. You're right. Yes, children. So we have to take up since we'll have to verify that this LHS is equal to this RHS. So take up the LHS, 3x plus 5y the whole square minus 30xy. This is what is given to us. So how do you work a plus b the whole square? A plus b the whole square is equal to a square, 3x the whole square, plus 2ab, 2 into 3x into 5y, plus 5y the whole square, b square. Then this minus 30xy as it is. So this is the identity. A plus b the whole square. We have used this identity. A plus b the whole square is a square plus 2ab plus b square. Then 3x the whole square means 3x into 3x, which is 9x square. 3x the whole square means 3x into 3x, which is 9x square. Now this will give you 6, 5 is 30, 30xy plus 30xy. And this is 5y into 5y, which is 25y square minus 30xy as it is. Now you can see that plus 30xy and minus 30xy, they get cancelled. So you're left with 9x square plus 25y square. And that's what you see in the RHS, 9x square plus 25y square. So this is equal to the RHS. So hence verified. Hence verified. You can write here, hence verified. Hence verified. Any questions, children, here? Any doubts?
No, ma'am.
No, ma'am. Ma'am, shall I say for the eighth one, ma'am?
Yeah, tell me. Tell me, Danya.
Ma'am, so they have asked to find the perimeter of the rectangle, ma'am. So they have given that they have adjacent side, ma'am. So it is length and breadth, ma'am. So perimeter of a rectangle is 2 into L plus B, ma'am. So 2 into 15, sorry, ma'am, 5x square minus 3y square plus x square plus 2xy, ma'am.
Okay.
Then, so when we add it, ma'am, so we get this answer, and then 2 into 6x square, ma'am, 5x square plus x square gets into 6x square, and minus 3y square, we don't have another like term, ma'am, so it stays as it, ma'am. And
Correct.
then, so And again for it is also same for 2xy, ma'am. So 2 into 6x square is 12x square, and then minus into plus 2 is minus 2 into minus 3y square is minus 6y square, plus 2 into 2xy is 4xy, ma'am.
Very good. Very good, Danya. Perfect. Your answer is right. So 12x squared plus 4xy minus 6y squared. Correct. See, it's given two adjacent sides. You can take this as the length, this as the breadth, or you can take this as the length and this as the breadth, because adjacent sides. So you can take anything as the length and breadth. But as Danya clearly mentioned, when it's given adjacent sides, that means the expressions represent the length and breadth of the rectangle. So here you can see the length is, I told you can take any expression as the length and the other one as the breadth. So the length is x squared plus 2xy. The breadth is 5x squared minus 3y squared. So perimeter is equal to 2 into L plus B, 2 into L, x squared plus 2xy plus B, this one. And as she said, x squared plus 5x squared is 6x squared. No like term, so this one as it is, this one as it is. Now, 2 into 6x squared is 12x squared. 2 into 2xy is 4xy. 2 into minus 3y squared is minus 6y squared. So this expression represents the perimeter of the rectangle. Yes, if you have any variation in your answer, please ask me. Okay. Children, while I was explaining, did I share my screen or no?
Ma'am, it was shared, ma'am.
No, this one, this question number 8, when I was explaining the answer to question number 8, was my screen visible?
Yes, ma'am. Yes, ma'am.
Okay. Yes, the answer for the 9th one.
Ma'am, can I, ma'am?
No, I think you said one answer. Somebody else? Raja has not done. Madhumita has not completed. Who else is there? Danya gave one answer, right? Sindhu, Sanjay, Devadarshini. Yes, Devadarshini. Try this. Try the 9th one. Not try the 9th one. You have tried it. Give the answer for the 9th one. What have you got? Devadarshini. You can't hear me, Devadarshini? Children, am I audible?
Yes, ma'am.
Yes, ma'am.
Danya, am I audible?
Yes, ma'am.
Okay. I don't know why she is not able to hear me then. Devadarshini, only when you participate in answering can I understand what you have understood and what doubts I have to help you with. But every time I ask you a question, I don't know why you don't answer. I become inaudible to you every time I ask you a question. I've been noticing this always, not once or twice, always. Every time I ask you to share your answer, I don't get a response from you. Anyone else wants to share the 9th answer? Okay, let me share my. Just tell me what you've got at least. It's okay.
Ma'am, can I?
Yes.
Ma'am, can I, ma'am?
Yeah, just simply share your final answer. Yeah.
Ma'am, I got the answer as x to the x cube plus x to the power 5 plus 1 by x cube plus 1 by x to the power 5, ma'am.
Perfect. Your answer is right.
The same answer, ma'am.
Very good. And that's the right answer. That's a correct answer. Very good. Share my screen. Raja, you're logged in from you have logged in from 2 different devices, is it?
No, ma'am.
You can see, and you can see, no, I've shared my, let me show you.
Ma'am, can you hear me now, ma'am?
Ma'am, I have logged in only one device, ma'am.
No, but can you see
Yes, I can see.
your name happening twice, Raja?
Yes, ma'am.
I'll remove the other one.
Yes, ma'am. I did not log in. Maybe in between I left once and.
Okay, I don't know.
Ma'am, can you hear me now, ma'am?
No, Devadarshini, we'll sort it out later, Devadarshini, not now. We'll not waste time now. Raja, are you in the meeting?
Ma'am?
No, you're there, right? Okay,
Yes,
fine.
ma'am.
Yes, children. So simple, we just have to, what do you call this expression, children? It has 2 terms. What's a special name to an expression with 2 terms?
Binomial, ma'am.
Binomial. What about this one?
Binomial, ma'am.
But here you cannot call them binomials because you'll see it in detail in 9th standard. Just because they have 2 terms, they're not binomials because they're not polynomials at all. Only for the polynomial, you can call it a binomial. So now I'll just try to explain why. Now, children, can I write this as x plus x to the power minus 1? Exponents 1 by x is x to the power minus 1. So the power of the variable x is negative. So the expression is an algebraic expression, but not a polynomial. If it is not a polynomial, you cannot call it a binomial. Because if it's a binomial, it should be a polynomial. To be a binomial, it has to be a polynomial. Similarly, this expression also, x to the power 4 plus 1 by x to the power 4 is nothing but x to the power minus 4. 1 by x to the power 4. 1 by x to the power 4 is x to the power minus 4. x to the power 4 is 1 by x to the power 4 is x to the power minus 4. So the power of x, so here the power of x is positive, but here the power of x is negative. So the powers in the expression, the variables must have whole numbers as their powers. The powers can be 0, 1, 2, 3, 4, 5, 6, any whole number power. If it is not a whole number, it is not a polynomial. So minus 4 is not a whole number. So this is not a polynomial. This one is not a polynomial. This is also not a polynomial. So you will have to multiply this expression with two terms with this expression with two terms. They're algebraic expressions. So how do we multiply? You need to multiply the first term with the second bracket, Then the second term with the second bracket, So this is how you multiply. The first term with the second bracket, the second term with the second bracket. That's what is expressed here. So it basically means x to the power 4 into x. I've shown all that here. Then x to the power 4 into 1 by x. 1 by x to the power 4 into x. Then 1 by x to the power 4 into 1 by x. You can see everything here. Then x power 4 into x is x power 5 because 4 plus 1 is 5. When bases are same in its multiplication, we add the powers. X power 5. Here what happens? It's division. Bases are same and it's division. X power 4 by x it is. So we subtract the powers. 4 minus 1, 3. So x to the power 3. Or you can cancel if you want to understand like this. X will go once and x to the power 3 here. If you want to cancel, you can cancel like x and 1x gone. So the remaining will be x to the power 3. That's also fine. Or you can use the law of exponents. When bases are same and its division, we subtract the power. So 4 minus 1 is 3. Here also the same thing. X once x to the power 3. 1 by x to the power 3. Or if you want to use a law of exponents, it'll be 1 by x to the power 4 minus 1. You can bring this down. Whatever travels will come with the opposite sign. 1 by x to the power 4 is in the denominator. This power 1 from the numerator comes to the denominator. So it will come with as minus 1. Whatever changes the place, that will go with the opposite sign. Like this is x to the power 1. 1 comes to the denominator. So it will become minus 1. 1 by x to the power 4 is in the denominator. So 1 comes down as minus 1. So x to the power 3. And here 1 by 1 into 1 is 1. X to the power 4 into, see like how do you multiply 1 by 2 and 1 by 3? 1 by 2 into 1 by 3. How do we multiply? 1 into 1 is 1. And 2 into 3 is 6. So 1 by 6. Similarly here, 1 into 1 is 1. X to the power 4 into x. And yeah, how do you multiply? Base are same, multiplication, add the powers. So 4 plus 1, 5. So 1 by x to the power 5. Yes, children. Take a screenshot. Sindhu, Sanjay, and Danya, good.
Ma'am, can you please show the 8th question's answer again?
Yeah.
Thank you, ma'am.
Yeah.
Ma'am, I will say the answer for 10th one, ma'am.
Okay.
Ma'am, here they have asked to find one side of that square, ma'am. So they have given the area of the square as 625, ma'am. So
Okay.
area of square is equal to side square, ma'am. So they have
Okay.
given square, side square is equal to 625, ma'am. So we have to find one side. So we have to square 625, which is 25, ma'am. And
We'll
then,
have to find the square root of 625, which is 25.
yes, ma'am.
Okay.
So they have given that one side is 4x plus 5, ma'am, and then one side is 25. So 4x plus 5 is equal to 25. 4x is equal to that 5 gets transposed to the RHS and then plus sign become minus, ma'am. So 4x is equal to 25 minus 5 and 4x equal to 20. X is equal to 20 by 20
4.
by
20 by
ma'am,
4.
yes, ma'am, 20 by 4, which is 5, ma'am.
Very good. Perfect. So the value of x is 5.
Yes, ma'am.
Very good. You're right, Danya.
Thank you, ma'am.
Yeah.
Ma'am,
Yes.
ma'am, the length of one side is 25, ma'am.
No, come again.
Length of one side is 25, ma'am.
No, it's not clear to me.
Ma'am, the length of one side of a square is 25, no, ma'am.
Yeah, side is, here we have to find only the value of x.
Yes, ma'am.
Yeah, the side is 25, correct. Okay. So children, area of the square is given to be 625. First step is correct. Area of the square is 625. Is the first step correct?
Yes, ma'am.
Now area is given by the formula side square. Area is given by the formula side square. Side square is equal to 625. Area 625. Instead of area, you can write side square is equal to 625. That's the second step, correct?
Yes, ma'am.
Now in the third step, what is the expression for side given? 4x plus 5. 4x plus 5. So for side square, so 4x plus 5, the whole square is equal to 625. Instead of side, we write 4x plus 5. 4x plus 5, the whole square, because side square. So 4x plus 5, the whole square is equal to 625, correct?
Yes, ma'am.
So if we have learned in squares and square root, if a square is 100, then a is equal to square root of 100, square root of 100.
10,
Similarly
ma'am.
here, similarly here, 4x plus 5, the whole square is 625. So 4x plus 5 will be equal to the square root of 625. That's the fourth step. Correct, all of you?
Yes, ma'am.
Yes, ma'am.
Now in the next step, 4x plus 5 as it is, square root of 625 is 25. The next step, transpose. So 4x is equal to 25 minus 5. 4x is equal to 20. X is equal to 20 by 4, x is 5. We have to find the value of x, sir. And the value of x is 5. Yeah.
Ma'am, today you gave us a question, ma'am.
Sorry.
Ma'am, today evening you gave us a question, ma'am.
No, I wrongly
Yes,
posted. No, that was not for you. By
Yes.
mistake, I posted it in the group.
Yes, ma'am.
Since it's a broadcast list, I can't delete it also.
Yes, ma'am.
If it's a WhatsApp group, I can delete the message. It's
Yes,
a
ma'am.
broadcast list, so I can't delete also.
Ma'am, I was confused in that question, ma'am. So,
I knew that.
also-
Yeah. In fact, I was telling my children at home that students now will be confused with what I've sent. That was not for you. Just ignore it.
yes, ma'am.
Yeah. All right, children. So that's it in this paper. Let's move on to the next one.
Ma'am, is your screen share? No?
Yes, children. All of you perform the long division. We'll do some because I think we have about 15 minutes time for this class. Let's work some questions in random. Do this long division, children. Remember the long division? You need to
Yes.
revise.
Yes, ma'am.
Remember?
Ma'am, can you please mention the question number?
Question number 8.
Okay, ma'am.
Please work question number 8, children. Yeah?
I'm completed, ma'am.
Yeah. All right. What's your quotient? What's the quotient?
Ma'am, 2x plus 1, ma'am.
2x plus 1.
Yes, ma'am. Ma'am?
And the remainder?
Ma'am, remainder is 0, ma'am.
So is x plus 1 a factor of 2x squared plus 3x plus 1? Is it a factor or not?
Yes, ma'am.
Yes, ma'am.
It is a factor. So how do we divide? How do we perform the long division? We have to divide. We have done this in the class, right, children? Division?
Yes, ma'am.
Okay. Not in school, children. Here in our class, have we done this? Division? I remember, yes.
Yes, ma'am.
Ma'am, we did it, ma'am.
Yeah, okay. So 2x squared divided by x is 2x. So that will be the first term in the quotient. 2x into x is 2x squared. 2x into 1 is 2x. Then we need to change the signs. Plus becomes minus, plus becomes minus. 2x squared minus 2x squared gets cancelled. Here also 3x minus 2x, because we have changed the sign, right? So it will become 3x minus 2x, which is x. And plus 1 comes down. Again, divide x by x. You get 1. 1. That's the next term in the quotient. Plus 1 is the next term in the quotient. 1 into x is x. 1 into 1 is 1. Change the signs. Plus becomes minus, plus becomes minus. X minus x gets cancelled. And 1 minus 1 also gets cancelled. The remainder is 0. So since the remainder is 0, when the remainder is 0, you can say that x plus 1 is a factor of 2x squared plus 3x plus 1. Did you learn long division through? Yeah, I shared some videos, right, children? I remember I shared some videos on long division.
Yes, ma'am.
Okay, so this is what it is. Take a screenshot if you want. Let's see the first one, children. Let's do it together. If a plus b is equal to 25, if a plus, you can take a screenshot of all the questions. If a plus b is equal to 25 and a square plus b square is equal to 25, find ab. All of you write the question in your book and follow my instructions. Write on the question. Solution should start like this. Solution, write this. A plus B is equal to 25 is given to us. Is equal to 25 is given to us. Square this on both the sides. So you'll get A plus B, the whole square is equal to 25 square, and continue working with this. Continue working with this. Write the question, start the answer like this. A plus B is equal to 25. Squaring on both the sides. A plus B, the whole square is equal to 25 square. And continue. Yes. What's the value of AB? Is it difficult, children? Not able to get it? Not audible, children?
Yes.
It's okay if you didn't. It's okay if you didn't get the answer. Is my voice audible?
Yes, ma'am, you're audible.
Yes, ma'am.
All right. Yeah. Okay. Okay. Let's do it together then. Not got the answer?
Yes, ma'am.
No problem. No problem. So how do we continue? We need to expand. What is A plus B the whole square? Next, see, first A plus B is equal to 25 is given to us. That's the first step. Then we square on both the sides. We square this on both the sides is equal to 25 square. What is A plus B the whole square? A square plus B square.
2AB B square.
Any order, correct. A square plus B square plus 2AB is equal to 625. Is equal to 6 because 25 square is 625. Now in the question, we are also given the value of A square plus B square. How much is that? 225. Substitute 225 plus 2AB is equal to 625. Is equal to 625. What's the next step?
625 minus 225 is equal to 2AB, ma'am.
Yeah, 2AB is equal to 625 minus 225. What is it? 400.
400
So now what is
2AB.
AB then? What is AB then?
200.
400 by 2, which is 200. 400 by 2, which is 200. Yeah. Don't go with this one, children. Learn any one method, children. Let's not get confused with both. Go with this one. Go with this one, children. The first one. You can also start like this. You can write the identity straight away. You can follow what I said is also fine. You can also do this, write the identity, because you know that a plus b, a square plus b square, ab, all these are linked in this identity. A square plus b, this is the identity. A square plus b square plus 2ab is equal to a plus b the whole square. A square plus b square plus 2ab is equal to a plus b the whole square. It's the identity. So you're substituting. What is a square plus b square? 25. 2ab as it is equal to what is a plus b the whole square? 25 the whole square. Same thing presented in a different way. That's all. Write the identity and substitute the values given. That's all. Write the identity. Write the identity. Then a square plus b square is given to be 225. And a plus b is given to be 25. So substitute in the right places and solve and find ab. You can also write the identity this way. A plus b the whole square is a square plus b square plus 2ab. Write it like this, substitute. Substitute the values given, solve and find ab. Is it easy, children?
Yes, ma'am.
Yeah, simply write the identity. You can also do what I said. A plus b is equal to 25 square on both the sides is also fine. Or you can write the identity like this. You can write the identity and substitute the values. A square plus b square is so first we write the identity, then a square plus b square, this one, the value is given, a square plus b square is given 225. 2ab, we don't know anything. A plus b, this one is given, a plus b is given to be 25. So 25 squared. 25 squared because a plus b whole square. A plus b is 25, so 25 squared. Solve this and find the value of ab. Yeah, we'll work these two and wind up the session for today. What does the numerator look like, children? What is 6.25 into 6.25?
A square. A square,
6.25 the whole
square, ma'am.
yeah, 6.25 the whole square. What is 1.75 into 1.75?
B square.
1.75 the whole square. So the numerator is 6.25 the 6 point, you don't have to say whole square because it's only one number. So 6.25 square minus 1.75 square. A square minus b square. A plus b into a minus b. 6.25 plus 1.75 into 6.25 minus 1.75. Similarly, the second one, 198 square minus 102 square. Please go through the answer. So first we write 6.25 into 6.25 as 6.25 square and 1.75 into 1.75 as 1.75 squared divided by 4.5 as it is. Now the numerator is like a squared minus b squared. So it's a plus b, 6.25 plus 1.75 into a minus b into 6.25 minus 7.1, 1.75 divided by 4.5 as it is. So this is the identity which we have used. Then 6.25 plus 1.75 is 8. 6.25 plus 1.75 is 8. 6.25 minus 1.75 is 4.5. When you subtract, you'll get 4.5 divided by 4.5. So 4.5 in the numerator and denominator, they get cancelled, and the answer is 8. Same thing here. Please complete this, children, because it's a very important question. Please work this now in the class. Any one method will do. You can just do this method. Children, please work this in the class. Any one method will do. Just work this, write the question and write this now. Finished writing, children?
Yes, ma'am.
Okay, please work this also now in the class. Work out this. When you have the same number, a number multiplied with itself, should write it as the whole square. 6.25 squared, 1.75 into 1.75 is 1.75 squared. Now we use the identity. Now because it looks like a square minus b square, a plus b into a minus b. Then add and subtract and we get these values 8 and 4.5. 4.5 numerator denominator cancels and the answer is 8. So the value of this expression is 8. The answer is 8. If you use the calculator and work this 6.25 into 6.25 minus 1.75 into 1.75 and divide by 4.5, you will get 8 as the answer. And that we did easily using the identity. We got the answer very easily using the identity. Second one also, see, we have to actually multiply 198 with itself, then 102 with itself, then subtract it, then divide by 96. We did not do all this. We easily got the answer, 300. This is the answer. When you work this using a calculator or the usual way, multiplying, finding this product, subtract and then divide, you'll get the same thing, 300. So we found the same. We've solved this using an identity. Completed, children?
Yes, ma'am.
Yes, ma'am.
All right, children. So that's it for today's session. Thank you so much. You can leave the meeting. Take a screenshot of this one. You may try. We'll work these questions in the next class. But just in case you're interested, you can complete this assignment. You can just give it a shot. We'll see the answers in the next class.
Ma'am, except the last one.
Yeah, whatever we've done in the class, you don't have to repeat. You can repeat for practice. Not that you should not do it.
Okay, ma'am. Thank you, ma'am.
All right, children. Thank you, children. Thank you.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.